Folks, this is the part 2 of oxidation reduction reactions. Okay. Well, in part 1, we learned how we identify oxidation states of the elements in ions or compounds. Okay. Now, let's take a look at how we use oxidation states to identify whether a reaction is oxidation reduction reaction or not. Well, the guideline here is if you have oxidation state change before and after the reaction, then it will be oxidation reduction reaction. Otherwise, it's not. Let's take a look at these two examples. First one, iron with oxygen generate iron oxide. Well, the first step is to identify the oxidation states of all of the reagents in this reaction. First one, iron. Well, we know that iron is a metal. It's just a pure element by itself. Therefore, oxidation state would be 0. The rule number 1. Okay. Oxygen, again, pure element. Oxidation state 0. Again, rule number 1. How about iron oxide in this case? Well, for iron oxide, okay, we let's label the oxidation state of iron as question mark. But for oxide, we know, according to the oxidation states guideline, oxide -2. Therefore, and this is the neutral compound. Therefore, the sum of oxidation states should be 0. Okay, so calculation setup should be question mark times 2 plus -2 times 3 equals to 0. Okay, so again, question mark oxidation state of each iron. 2 comes from the 2 here. -2 oxidation state of 1 oxide. 3, you have 3 oxygen. 0 because it's a neutral compound. Now, if you do the question calculation of the question mark, that's going to be +3. Okay, so we label +3 on top of iron. All right, now let's compare the oxidation state before and after the reaction. Before reaction, iron is 0. After reaction, +3. Before reaction, oxidation state of oxygen 0. After reaction, -2. So before and after reaction, you can see that the oxidation states of both elements changed. Therefore, this is an oxidation reduction reaction. All right, now let's take a look at this example. Well, for potassium iodide, well, we know that potassium would be +1, iodide would be -1. Okay, remember potassium, group 1A metal, it's always +1 oxidation state. For iron, we know that for iron, for silver nitrate, sorry, it's not iron, it's silver nitrate. Silver, the charge is +1. Okay, therefore oxidation state of the silver is +1. And for NO3, as we did before, okay, question mark, if you happen to remember, question mark plus -3, -2 for each oxide times the 3 equals to -1. Okay, so question mark should be calculated as +5. Oxygen, each one -2. Potassium on the products, potassium nitrate, again, it's +1. NO3, nitrogen in NO3, it is still +5. Oxide, -2. Silver in silver iodide, silver is +1, iodide is -1. Okay, now let's compare. Oxidation states of potassium remains the same. No change for iodide, remain as -1. Silver remains +1. NO3 remain as +5 for nitrogen, oxide for -2 for oxide. okay, on both sides. So there are no oxidation state changes before and after the reaction. So this is not an oxidation reduction reaction. Okay, now we've already discussed how we identify whether a reaction is oxidation reduction reaction. Now let's get deeper into this topic. Let's learn how we identify oxidizing reducing agents. Okay, well, I want to remind you, when we talk about oxidizing reducing agents, we are talking about the reactants only. Okay, reactants only. A common mistake is to assign, products as oxidizing or reducing agents. That's not correct. Okay, so I have a note here for you. They are, these oxidizing reducing agent. We're going to just focus on the reactants only. Now, let's talk about the oxidation reduction in general. Well, if you have reactant A and reactant B react with each other, and let's assume that A will lose the electron, B will gain electron. So that's why I have the arrow here. Electron is transferred from A to B. N here represents the number of electrons transferred. So N could be 1, could be 2, could be 3. It depends on what reactions you are talking about. Now for A, it loses electrons. Okay, so we say that oxidation happens on A, reactant A, or A is oxidized. Okay, well, in this case, because it's oxidized by another product, another reactant, so B is going to be oxidizing agent. In other words, B oxidizes A, so B is oxidizing agent. Sometimes oxidizing agent is also called the oxidant. Okay, all right. Now let's go further. And how do you know that A is oxidized? Well, you take a look at the oxidation state. If oxidation state increases, that means A is losing electrons, so it's going to be oxidized. All right. Now, how about B? B is getting electrons, and so we call it reduction. Reduction happens on B, or B is reduced. Okay. Well, what is B is reduced by what? By A. So A is reducing agent. Okay, it's a little bit awkward, but as you notice that everything is the opposite. Okay, A is oxidized by B, therefore B is oxidizing agent. B is reduced, therefore A is reducing agent. A reduce B. Okay. Well, how do we know that B is an oxidizing agent or B is reduced? Well, we take a look at the oxidation state. If the oxidation state of B is decreasing, then that means B is reduced or reduction happens on B. All right, let's take a look at these two examples. Again, let's label the oxidation state. For iron, before reaction, it's 0. Oxidation state of oxygen, 0 before reaction. Well, iron oxide, iron is going to be plus 3, oxygen negative 2. Okay. Now, we know that for iron, oxidation state increases from 0 to plus 3. So iron is oxidized. Okay, iron is oxidized, so oxygen is the oxidizing agent. Oxidizing agent. All right. Now, for oxygen, you can see the oxidation state decrease from 0 to negative 2. So oxygen is reduced. And oxygen is reduced by iron. Therefore, iron is the reducing agent. Reducing agent. Okay. As you can see, again, we're going to focus on the reactants when we discuss reducing agent and oxidizing agent. Okay. Now let's take a look at the second example. Well, iron oxide is react with carbon monoxide, generate iron and carbon dioxide. Let's label the oxidation state also. Well, for iron oxide, we know it's here already. It's positive 3. I'll use the red color. So positive 3, oxide, negative 2. Now carbon monoxide, well, we know that oxide is negative 2, therefore carbon would be positive 2. Okay. For iron metal on the product, it's going to be 0. Carbon dioxide, oxide, negative 2, carbon, positive 4. We did this before. Okay, now let's see oxidation states change. For iron, oxidation state decreases from positive 3 to 0. Therefore, iron is reduced, and it's reduced by carbon monoxide. Therefore, carbon monoxide is reducing agent. Okay, reducing agent. Now, for oxide, it remains the same, so no oxidation state change. But for carbon, the oxidation state increases from positive 2 to positive 4. Therefore, carbon is oxidized, and it's oxidized by iron 2O3. Therefore, iron 2O3 is the oxidizing agent. Okay, oxidizing agent. Okay, so this is how we identify a oxidizing agent and reducing agent based on the oxidation states change. Okay, we will do more practice in class, and let me know if you have any questions.